Kirk Math. All right, welcome, ladies and gentlemen. We are starting our Module 2 lesson notes. So we're going to start here by reviewing something that we should have learned in 5th grade, which is multiples and factors. So this is our lesson notes that are titled Review of Multiples and Factors. So please find those notes so that we can review what these are. All right, so we have some vocabulary words that we're going to start with. So a factor is a number that you multiply together. So we need to know this because, well, hold on a second. We need to know the difference between a factor and a multiple because when we go, what we're going to use this with is finding GCF and LCM. And when we go to do this, a lot of students confuse factors and multiples and they get their problems wrong, even though they did all the work right, but they did it for the wrong problem. So we're going to try to remember that factors are the numbers that you multiply together to equal the number in question, that certain number, okay? So if I say, what are the factors of 12? You would tell me, oh, the factors of 12 are 1 times 12, 2 times 6, 3 times 4, right? So all of these is multiplication in the middle. And you would say, these are all the factors of 12. A factor pair is the set of two factors that you multiply to get that given number. So up here, I list my factor pairs. 1 and 12 are factor pairs. 2 and 6 are factor pairs. 3 and 4 are factor pairs. It's the two numbers that go together to multiply to equal that number. All right, then we have certain special factors, okay? A prime number is prime when the factors are only 1 and itself. So if you go to list the factors of, let's say, 7, I know 7 is prime because the only factors is 1 times 7. There are no other numbers in the entire world, whole numbers, I should clarify, that when multiplied together make 7. No whole numbers. That's prime. Composite would be the opposite of prime. A number that is composite has more than 2 factors. So an example of a composite number would be 12. 12 is composite because it has more than 2 factors. 7 is prime. So this is prime, and this one is composite. Sorry for the email dinging in the background. All right, so if you didn't get those numbers, this is what it looks like. All right, so let's list some factors, okay? So we're going to find the factors of 36. So over here in my single shoe, we're just going to list them out. And over here with my 2 shoes, we're going to find those factor pairs. So again, I think the best way to find factor pairs is to kind of list them out, right? So we're going to have 1 times 36. That's a factor pair. 2 times, what makes 36? 18. That's a factor pair. 3 times 12. So you could use a multiplication chart to help you, but remember, we can't use those on our tests. But if you're trying to practice what your factors are, you could also do your long division and go, can 4 go into 36? And see if you can go that way. But yes, 4 can go into 36. That's times 9. 5 cannot. 6 can go into 36 6 times. 7 cannot. 8 cannot. And then we're back at 9. So you know you're done with your list of factor pairs when you come back to a number you've already listed. So in this case, I listed both 6s. I could have known then, 6 and 6, I have a duplicate. I'm done. All of these factor pairs are listed. If I had no doubles, as soon as I got to that 9, right? 9 goes in. I'm not going to write 9 again because I already have a 9. So as soon as you repeat a number, you know you're done. Now over here, I'm going to take all these factors and we're going to list them out in order from small to big. So the factors of 36 are 1, 2, so again, we're putting them in order. 3, 4, 6, I'm not going to list 6 twice, 9, 12, 18, and 36. Then we can make what we call a factor rainbow. So a factor rainbow is looking at factor pairs, but when they're written out. 6 times 6 is 36. 4 times 9 is 36. 3 times 12. 2 times 18. And 1 times 36. And you can see that it makes a pretty rainbow if we list my factor pairs out. So if you're ever listing your factor pairs out and you think maybe you want to know if you forgot something, do your rainbow, because then you can kind of match them up and know, oops, I forgot the number that goes with 4, or whatever it may be that you forgot. Okay, so that is explaining our GCF. Now GCF means greatest common factor. Okay, and you might be asking yourself, well, what does that even mean? Basically, we're looking for the largest shared factor of 2 given numbers. We want the largest number that both of the given numbers have, the largest factor that both of the numbers have that is shared between them. Okay, next we're going to write the definition and stuff for multiples. Okay, so a multiple is the product of a given number and some other number. Okay, a hint that you might think is skip counting. That's basically what we're going to do. When I think multiples, I think skip counting. So if I want to find the multiple of 2, I'm skip counting by 2s. 2, 4, 6, 8, 10. Those are multiples of 2. Okay? Nice thing about multiples is they are infinite. You're going to they go on forever and ever. They're limitless or endless in value. So I can list my multiples forever and ever and ever. And that's why when we use multiples, we're actually going to look for the lowest common multiple. Because if I look for the greatest, I would be looking forever. So here I have 12. We're going to go ahead and skip count by 12s and fill this in. Obviously, we're not going to do all of them because it's an infinite stretch. And then to the side here, we're going to show you how did I get that, right? So 12 is because it's 12 times 1. 24 is the next one, which is 2 times 12. 36 is the next one, that's 3 times 12. I'm just skip counting by 12s. 48 is 4 times 12. 60 is 5 times 12. 72 is 6 times 12. 84 is 7 times 12. 96 is 8 times 12. 108 is 9 times 12. 120 is 10 times 12. 132 is 11 times 12. And 144 is 12 times 12. And again, these are just what we have. They go on forever. I could keep going. So we're going to take a look specifically at, we'll do this guy, 36, because we were talking about it earlier. And we're going to add a little note here, okay? So 36 is a multiple of 12. And 12 is a factor of 36, which we found out earlier. So just so you know, you can have, right, they go together, basically. All right, so again, we're using this because we're finding the least common multiple, or LCM. And basically we're looking for the smallest shared multiple in two or more given numbers. And that's also true for greatest common factor. You could have more than two. We're going to pay attention to two a lot, but you could have more than two. All right, and that is where we are. We're going to pause here, and we'll do a new video for prime numbers because that takes a little bit longer. But just make sure you have your notes filled in. Oop. There it is.